Hello guys, welcome back for another question from the chapter integral functions, and let us see what do we have as a question. We have to integrate this expression, the expression given on this screen, and what does expression look like. So in the numerator we have cos x, and in the denominator we have root of 1 plus sin x. Now looking at the expression, I get an idea immediately that denominator under the root part, that is 1 plus sin x. If we differentiate it with respect to x, we get cos x, that is equal to numerator. So we can see that this is a question of substitution in integrations. So let us see the first step. Our first step is that we write 1 plus sin x is equal to t, and then we differentiate it on the both sides. So we get cos x dx is equal to dt. This thing we get while differentiating it. So now moving to the next step, we have cos x dx upon root of 1 plus sin x. So 1 plus sin x can be written as t, and cos x dx can be written as dt. So we get integrand as dt upon root t. Now this is a pretty easy integrand. So our final answer is t raised to the power half upon half plus an additional constant as c. But before signing off our final answer, we need to see whether our final answer is in the variables that we were given with. No, we were given with the variable x, but our final answer is in t. So we cannot put our answer in the terms of t. We have to replace t by x. So what's the how to do it? We can see that we replace t by 1 plus sin x here. So this t can be replaced over here. Now moving to the next slide. Okay. So we back substituted the value of t, and we get our final answer as 2 into root of 1 plus sin x plus t. So that is it. I hope you all got it. Thank you. Have a nice day.